There it is.
There it is. I think we're ready.
Mhm.
Okay.
We're the members and the board and the hardcore supporters of the Central California Coast Longtime Astronomy and Telescope Club, your Santa Barbara Astronomical Unit, convening again on our screens for the SBAU Astro Hour. I'm your host, Ronnie Herron. I'm on the board. We'll introduce you to the rest of the guys. It's a weekly online vlog using Zoom that focuses on the latest space news and discoveries, cutting edge cosmology, hardcore astrophysics, and featuring
Wow.
some of our brightest, most knowledgeable folks I know in town. I don't include myself in that, but I get to ask the questions. So let's get ready. SBAU's vice president, that's me. We will meet the rest of the club's members. I'm just reading 11 to noon, and we're a week away from guess what? We even have a sort of a political cartoon to show you in a minute. So 11 to noon every week. This is going on our fourth year in a few months. Uh, Show number 192 of the Astro Hour this week, talking about daylight saving time coming up next weekend. We got something to say about it. The Comet Atlas Sochian Shan, still an evening sky show. And we're calling it Comet T, I guess. The new moon on Friday morning. And for All Hallows Eve on Thursday, we're hunting down a planetary nebula called the Blue Snowball. Another name, gravitational lensing, deflection of starlight. It's over 100 years old. And we're not just galaxies being lensed by distant galaxies, it's stars these days. Okay, we'll also visit the Cave Nebula and see if there's an Ursa inside. Big bad bear. Let's meet everybody. Jerry Wilson, beloved president. How are you, Jerry? He's in
Good
charge.
morning. Good.
You're going to run again, I assume, in December for the elections. I'm
Sure.
assuming this because I am. I think we're running unopposed. Pat Forgy is his wife. Got an incredible outreach coordinator, Chuck McPartland, who goes everywhere. Astro will travel. And Chuck has been with us forever. He's probably one of our longest members. Pat
No, not
McPartland,
even close.
not even close. We go back to the last century. Does everybody? I guess all of you guys do. I'm the newcomer. Chuck is married to another Pat. Pat McPartland is our merchandise manager, having a continuous garage sale since we're getting out of the business, selling our merchandise. She's also an incredible treasurer who may have to run again or may give it up the post come December elections. Tom Whittemore joined us, editor of
Thank-
our newsletter on screen, and he's former science instructor, as we say, out at Westmont College. He knows well the lady speaker this coming Friday night. We're going to have Jennifer Ito, who runs the astronomy department out there, her assistant professor, and runs the observatory. Tom's married to Maureen, and he's behind what I call the Whittemore wit. What was
Oh,
the one you told me about before? I
oh,
think
if you tell a joke on Zoom, would
yeah.
it be considered remotely funny?
Well, it certainly is in your case, but I laugh anyway every time. There's Tim Crawford. Oh, incidentally, Tom's married to Maureen. Tim Crawford's married to Karen. How are you, Tim?
I'm doing great.
Well, come on, give us details. What's really ailing you? Tell us about your aches and pain. That's what we do at our age.
Oh no aches, no pains, no.
Oh, I see. Okay, you're the one that
It's better to give than receive.
just I see him limping by on the star parties.
Oh
And
yeah.
his wife is Karen. He's an expert on a regular, I guess, on tomorrow's Tuesday workshop. Are we still doing the workshop?
Oh yeah.
That'll be online tomorrow night. And son of a gun, if there isn't, Bruce Murdoch, longtime supporter and telescope enthusiast, fan of ours, happens to run the Santa Barbara Theater Organ Society and is married to his wife, Bonnie. Okay, and I learned about well, here it is. My very elderly mom just served us nachos. Those are the planets. My very
Nachos.
elderly used to be nice pizza for the P, would never mind. Let's get into the sillies because our president sends us all these silly science cartoons, and I've familiarized myself with them. So we're going to call them up now on screen. And if any of you have a comment about them, we start this off with oh, here's my favorite. Two crack astronomers arguing. Bruce Murdoch says to Tim Crawford, I'm sick of all those political phone calls. Crawford says, me too. I hate getting all that political junk mail. Bruce goes on, what I really can't stand is all those political ads on TV. And Tim says, I can't wait for it all to be over. Bruce comes back, yeah, but I'm sure that won't be the end of all the whining and moaning. Let's just get back to astronomy with a good refractor, to which Tim counters, wait a minute. No, you moron, you do it right. You got to use a reflector for crying out. That's what
Pretty good.
astronomers argue about. I had to transfer that because I knew I wouldn't be able to read what I'm seeing on my screen. Is it a little washed out?
Oh,
Yeah.
yep.
Okay,
We gotta go to the other one, Jerry.
okay.
Can we clear that up?
Yeah, just a sec.
Guess my little soap opera there pretty much filled us in on that last cartoon. Content of this meeting is being sent to a third party. Oh my God, who could that be? It says that at the top of the screen.
That's better.
That's a little better. That's the two versions of Lucas. What's Lucas's first name? George Lucas?
George
Yeah.
Lucas.
George
Yeah, he
Lucas.
came up with, there's the Americanized version, Imperial Stormtrooper, and then over in Britain, the metric Stormtrooper, 5'11" here, 5'11", 180 centimeters there. Otherwise, we've got something about metrics coming up right there. Neil deGrasse Tyson said it. Don't give up on us yet. Americans are inching towards the metric system. Just a few centimeters away, I think. He was on CBS this morning. Here's the Wizard of Id. Wizard of Id has been declared, I guess, the official royal nerd on the campus, on the castle. It's up on the ramparts. I'm going to change that opening line to uh-oh. He's looking through his telescope. And the king says, what the heck is uh-oh all about? Incoming. Here's a big burning asteroid, giant one on its way to Earth. And I guess it makes contact. Doesn't hurt them, but Wizard says, you know,
that's a beam from the wizard's wand, his magic wand.
oh, the one got the
Yeah, he zapped the asteroid.
Oh, he
That's
zapped
what
it.
broke it up into bits and pieces.
Oh, I thought the bottom left showed it hitting the Earth. That's it being okay. Got it.
No, it hit his lightning bolt going up.
Got it. Okay, and so he announces, "You still say I'm a nerd, wasting my time with my telescope?" And King goes, "Was it royal nerd who just got a raise?"
My favorite Wizard of Iz a long time ago, Wizard of Id, was
I used to see
the guard comes running up to the king and he says, "Sire, the peasants are revolting." And the king turns around and he says, "They certainly are."
that for years. That's right. All right, here's the Square Earth Society, a bunch of stupid felines being run by one main person, one main kitty cat. The thing about a square Earth or a cubic Earth, I've always often thought about this, is it would have 8 incredibly tall mountains on it, wouldn't it?
6.
1, 2, 3, 4. No, 8.
6 tall mountains.
No.
Okay, if anyone speaks Polish. Oh, there's 8 corners. Okay, that way. All right, sure.
All right.
Yeah.
This is the Thorn Zitkow. Is that how it's pronounced? Thorn
I'd say, being Polish, I'd say Żytkov.
Well, careful. We're a family program here, gentlemen. This stick figure professor on stage lecturing says, you know, the Thorn Zitkow object is a hypothesized nested star. It's a red giant within a neutron star, or no, with a neutron star inside the red giant. So far, none of these, no TZOs have been definitely observed, but your grant could help us change that. Down at the bottom, we're struggling to get funding for our project to slingshot a neutron star into our sun. You got to put this on the list for future talking about Ditko or whatever. Who speaks Polish on the group?
I do.
You speak Polish?
Yes. Talk.
Closest thing I watch is a little cutie by the name of Eva Zubek. Check her out. She's Polish, but it has a British accent on YouTube. Okay, we're going to the skies. Up and away.
Yes.
Wow.
And which star cluster is this, Jerry?
Well, this is actually, that might be a little out of order here. Let me just check this. Yeah, here we are. This should have been the first one.
All right, that's
This is about the comet, and it's where the comet roughly is. This is the
Mhm.
evening sky. Around 6 o'clock, the sky will not be this dark, but it's a good separation from this area, which is where the comet is, and NGC 6426. They're in the same general area right up here. So it'll be fainter. You won't see the comet with your naked eye unless it's really, really dark. I mean, really clear sky with no lights. But a binoculars or a telescope will show the comet very well. The star cluster that it's near is, oh yeah, there's the cursor there. This is the star cluster it's near.
It's pretty.
So it's a small cluster. It's actually a globular cluster, but a very loose one, very old one. It's been around the galaxy many times and it's lost a lot of its stars. So just like comets that leave dust in their orbit, globular clusters can leave stars in their orbit as they orbit the galaxy.
Can I ask a question about Suchinshan?
Yeah.
80,000 years is its orbit. How much of that time, how long does it more or less come to the inner solar system and go around the sun?
Recording in progress.
Oh, shut up.
Couple of weeks, Ron, because that's how long we're seeing it.
Just a few weeks.
Someone's
Quit it.
Bruce, are you the culprit on
Yeah,
that?
I'm trying to turn off the other microphone.
Okay.
Doesn't want to turn off.
It worked last week and it's working now. Fantastic. There's an AI on our side. All right, what is this, the comet?
There are two pictures of the comet. This is the close-up. The other one is a wider angle shot taken from an observatory in Spain. It's fantastic. It shows the nucleus, shows the bow shock here. It shows the structure in the tail. Very nice image. You can even see a faint anti-tail going around here, which is a trick of perspective or point of view. This is the wider shot.
Well, obviously on a long elliptical orbit, it goes faster on the shorter side that comes in close to the sun.
Way faster.
Okay, then how far out does it go and how long does it take the sun and the solar system to get around the galaxy? Within that 80,000 years or more than 80,000?
Oh, no. It takes us
Something like 250 million, 250 million.
Chuck got it right.
So when it gets out of there, it has to be the Oort cloud. It's really going slow.
Depends where it came from. And on this comet, I don't recall where its apogee is.
But that's roughly Oort cloud territory.
Yeah.
Okay, well, that seems so different from the 80 years of Halley's.
Yeah, well, that's a comet that's been perturbed by Jupiter, and it's now a short period comet. It only goes out to between Uranus and Neptune.
Oh, so it's not 80,000 years anymore.
No, I mean, that's Halley's we're talking about.
Yeah, 76 years.
I'm sorry. All right. Okay. Interesting.
So this one was processed to show a bunch of detail in the coma.
Right.
There was another one that showed a bunch of spiral, stuff from a vent that was, and the comet nucleus was rotating.
That was another comet, I think, or was that this one?
That was this one a couple of weeks ago, or a couple of week and a half ago.
Okay, I missed that stuff. Yeah, there's a lot of structure in the detail in the comet, in the tail.
But
Excellent
obviously,
photograph, processed very well.
Obviously, the solar wind blows all that cometary stuff directly away from the sun. And that's the most primary tail we get.
Yes.
And there seems to be a line in the middle of it. Do you not see
shadow
that?
of the coma of the nucleus.
Mhm.
And yet it's up and down in the sky, isn't it? Isn't the tails Oh, that's because it's above the sun after it sets.
Well, it's kind of tilted now.
Yeah, it kind of points at the sun. Okay.
Can I take just a moment to ask another quick question that's been bothering me lately?
Go
Does
ahead.
anybody know how the solar system is moving around the galaxy? Is it side view like
It's
throwing a
tilted.
frisbee? It is tilted.
Yeah.
So all the planets are following this track, of course, and they're going in a spiral.
Yeah, that really has no effect. You can look at it just as the sun with its planets orbiting as a unit. And the path around the galaxy does not have any first order effects on the solar system. Someone just figured out that it's moving around the galaxy, and so our planets are really making a slight spiral instead of a simple path around the galaxy, which is true. It's always been true, but it doesn't really matter.
And
I heard,
also, our sun kind of oscillates up and down a little bit relative to the central plane.
Right.
well, I thought I saw a figure of thousands of miles an hour the sun is
No,
going.
they're moving at high speed, but relative to what? You know, the thing that cracks me up is people say, what if you travel at 99.9% the speed of light? What would it feel like? Well, if you have speed is relative. So if you have an object anywhere in the universe and it's moving at 99.9% the speed of light, then we are moving at 99.9% the speed of light relative to that object. So moving at any speed feels just like this. You can't tell which one's doing the moving.
But there is a gyroscope effect that prohibits something spinning from being turned.
Yeah,
And
but
the planets are spinning around the sun, and seems to me it would affect it the way we're going, the direction.
What would
it
be
doesn't
pushing on it,
prevent
Ron?
from being turned.
I'm
It's
sorry?
just the non-obvious response force to being turned. It's a cross
Okay.
product.
Hmm.
So
Thank you for the answers. I think I got answers there.
we'll look at cross products and dot products later.
I prefer to call this the Atlas. Suchin Shan.
Comet T.
There was another comet Atlas run, and it disintegrated, or the nucleus disintegrated. So you can't do that. Atlas has discovered a whole lot of comets.
So that one is gone then. Okay.
The
Well, it
follow-up one, yeah.
might be. They're calling it the ghost comet because the nucleus seems to have dissipated, but the tail is still there, and it might become visible around Halloween.
Oh, that'd be great.
Usually
the ghost comet. How cool is
that? Okay. Take us through the maze, Mr. Prez.
Okay.
This looks like a blue snowball.
Mm-hmm.
Yeah.
Oh.
Yep.
And
This
where would that
is, we're coming up on the, obviously on the fall season, start of the holiday season with Halloween, and the first object, well, there's a list, like the Messier Marathon, which we do in the springtime in March, but there's a winter list that Stephen James O'Meara put together called the Ghost Hunt Challenge List. And it's got, like the Messier Marathon.
Oops, that's washed out.
That's watched out.
Okay. Like the Messier Marathon, it is
held once a year?
well, like the Messier Marathon, there's 110 objects.
Oh,
So how's this washed out? Not
no, it's fine.
That's
Okay.
pretty good.
So there are a lot of M's in here, but there's also a lot of NGCs. Unfortunately, the Sky and Telescope talks about this list in the same paragraph they talk about the blue snowball, and the blue snowball is not on this list. But it's a cool list, and the challenge from Steve O'Meara is to see all these things in one night. He's worked out that it's theoretically possible. I don't know if he's actually done it. So it's up to 109 objects there. The Screaming Skull. Last one.
Oh, there's the blue snowball.
What's
Two up
that?
at the bottom.
Where do you see it?
It's 2 up from the bottom. It's 107.
Oh, you're right. Okay. Well, scratch that line out of my talking points.
Okay.
I looked all through this and didn't find it.
Yeah. That,
Do it too late at night and I'm too tired. So anyway,
But it is a nebula.
It's a
this is the
planetary
blue
nebula.
snowball.
Okay, what's the white thing in the middle?
That's
That's
the
the white dwarf.
leftover
White
white dwarf
dwarf.
star.
It's a
Okay.
planetary nebula, Ron. It has a white dwarf at the core.
Yeah.
you know,
Other
and
than-
Jerry, on that other slide, the star hop for this is on the great. You find the Great Square of Pegasus,
Oh yeah, we'll go back to that.
and I never know. I never know which is east and west and all that stuff in the sky. But if you look at that little arc of stars,
So the
Oh, we're-
problem with this way of viewing things is it loses track of the order.
okay.
So I'm hunting.
Well, we're enjoying the fast trip. Okay.
Yeah.
I think it's there, right?
No, it was a couple back. You zoom by it because it showed only a partial map here. Maybe there.
Um,
And the significance
There
of the
it is.
calendar?
yeah, this is it. Yeah.
Yeah. So you see
This
that
is the blue snowball. And there, as you point out, is the Great Square of Pegasus.
right. So Shiat and Alpharats to the left of that in our view, the left side of that square. Those two stars. I just go out that side, and the two stars that are in a line with the blue star snowball, those are visible naked eye. Out to the left where the blue snowball is, and you just get right there where you were.
You can just bisect this line and bisect this line, and then
Oh,
take the two points as a new line.
now see the star above and below your target?
Yeah, right there and
No,
there.
No,
by the target.
where your
Oh,
target
over
is.
here.
Yeah, that star and the lower star. Those two right there. You just draw a line there and go up about a third of the way, and from the lower one, and you kind of run into the blue snowball. And that's what I use as a target. But I really like how you bisected the square. That really helped. That kind of draws you right to it.
Yeah.
It also looks like, Tim, it also looks like it's an apex of an equilateral triangle,
Yeah.
you know,
Yeah.
just kind of looks that way.
Plus, you just look for the concentric circles.
That's
Yeah,
like
just
supernova.
like
You just
Pluto,
look for the two lines that cross, in the chart.
Or the arrow.
Yeah, the arrow.
Yeah.
Where would we be without that arrow?
Is the blue?
I
Is
saw
the
a great cartoon, a little cartoon video that showed this person at an apartment in Paris, and they're using their cursor on the map. What is it, Google Earth and stuff. And then they go out and they look out the window and they can see all these arrow cursors moving over Paris.
I read it now. Is the blue snowball, is that to the west of the Great Square or the east?
I think this
Seems like it's
west is
north.
this way.
Looks like west.
Okay.
Yeah.
I
Here's
get that
M33.
so confused.
I mean M31.
Yeah, and it's above M31. There it is.
Mhm.
Is the blue rare?
Is what?
Are they not usually blue? These planetary nebulas.
They're
Which are-
blue-green because of the oxygen emission.
Yeah.
So this is a rare one. This is an oddball.
Oh,
No.
no.
No, but this particular one, Ronnie, is in the eyepiece. It has this bluish tint to it when you look at it.
Yeah.
Yeah, this one is bright enough and small enough that it'll tickle your color sensors in your eye and you get an idea of the blue-green.
There it is.
Mhm.
But like all planetary nebulas, it can be hard to spot in like a finder because there's not much magnification in the finder.
Yeah.
It looks like a star. So
The
you can
bat star.
slide right over it. You got to look at it in the main scope under a little higher magnification, say 100x or something.
But this is the aftermath of a nova, a supernova.
No,
No.
it's a planetary nebula.
It's what our sun's going to become, Ron.
As big as the whole blue, or just
No, I meant just the white dwarf in the middle. So the sun is on a course in billions of years to become like a white dwarf.
If you ran the video backwards, all this blue and red stuff would collapse down onto the star, and then it
Right.
would be like our sun.
Mhm.
But the fusion
So-
in its core in
Right.
this type of a star, it stops. It just simply runs out of fuel.
Yeah, Ron, all that blue you see there used to be the star's atmosphere.
but
It's
it
be-
didn't explode though.
No,
No.
it just sloughs it off.
What it does is it's a core collapse, not a core collapse supernova,
Right.
but the radiation, the fusion is producing radiation that provides the outward force that works against gravity to keep the star as it was before it ran out of fuel. Once the fuel stops, the radiation stops, and now gravity wins. And all of a sudden, all that mass has nothing to hold it up, and it falls down
Right.
and slams off the core and rebounds like this.
Oh,
Well, that's more like what happens in a core collapse supernova. In this case, this is more you get you get sputtering as the star starts to run out of hydrogen in its core, and it swells up into a red giant, shrinks back down. It goes through several of these,
Mhm.
and then when the core shrinks enough to start fusing helium to form carbon, you get what's called a helium flash, which is not like an explosion, but more like a burp in stellar terms. And it poofs off more of the layers, and then the core collapses to this white dwarf, and the radiation now is ultraviolet that makes it fluoresce.
Right. And Ron, that used to be the core.
Okay,
That
but
hot
what-
cinder out there used to be the core of that
Right.
star.
So
And
all that
it turns out it's usually around 100,000 kelvins, something like that. Okay.
Well, it evidently does emit some visible light because we can see it.
Yes,
Mhm.
it's very hot.
It's very
So
hot.
the peak of the emission is in the ultraviolet.
That's right.
okay.
UV, it's real bright.
now a lot of these planetaries, they're bipolar. So in this case, are we just looking at it like an end on?
It could be, but they're bipolar when it's a double star,
Yeah.
a binary.
Oh, really?
Yeah, or a strong magnetic field of some kind.
So it could be a single star, and it just would be sloughing off just a kind of a shell of gas, huh?
Exactly. Yeah.
Okay.
Yeah, that's exactly what happens, Tim.
It depends on what its rotation speed is and whether it has dust or planets around it or a companion, as Chuck points out.
Right.
Some
But
of them
that-
have really complex shapes because
Yeah.
they have like a magnetic pole that doesn't match the rotational pole.
Yeah. I think I would
Or-
call this the blue kidney bean.
Yeah.
For
This looks
beginners,
like-
you can take my explanation, which is the 0th order term of the power series of knowledge. Or if you're into more detail, you can take Chuck's.
This is a lot like the Eskimo nebula.
Yes,
Yeah. Yeah. Or clown face. Yeah, we
yeah,
call it
very
clown face.
similar.
so
And-
what we're
And the blinking planetary.
That's a favorite of Tim's. Clown
Yeah.
face.
Yeah,
And what's the star next to it, Tim?
Oh, I don't know.
Oh, isn't that Wasatch?
Oh, no, that's the Eskimo.
You always say, what's that?
That's what's that?
be quizzed later, gentlemen.
Yeah.
Are we looking at mostly hydrogen?
Well, what you're seeing
Oxygen.
the blue is the oxygen.
yeah.
Yeah. Yeah.
Oxygen.
Yeah. Twice ionized, Ron. Twice ionized. It's called oxygen 3.
Okay, well,
The pinkish stuff is a hydrogen.
Yes.
really? So,
Mhm.
and that white dot in the middle is not a 10-mile across neutron star or something we couldn't.
Probably Earth-sized, maybe?
Earth-sized white dwarf.
Yeah,
Yeah.
The
Mhm.
white dwarf.
it's
yeah.
a collapsed star, but not as much as a neutron star.
We can see something the size of Earth that far away? Wow.
Well, it's bright.
It's
Yeah.
not size that you see in the sky, it's brightness that makes it look,
Right.
makes it
right.
visible. The
Gotcha.
the star is
reflect-
no longer producing fusion in the core. It's now just hot. It's like a ball of material that's hot and it's cooling off by radiating its heat away.
Right, like a
Toasting.
cinder. I tell my students, I used to tell my students a cinder.
Yeah, cinder is a good example.
Yeah.
Still
But
hot.
this-
Eventually, it'll just turn black dwarf.
Yes, that's right. Mhm.
Eventually.
But now other nebulae are not like this, right? They're just vast gas clouds, right? With
Well,
nothing.
that's a
in the-
gas cloud.
I know that, but it's a planetary nebula.
Yeah.
What are the other nebula called to differentiate them? The
Nebula.
ones that are just nebula.
Just-
Well, there's two kinds, star-forming nebulas and ones that
Yeah.
are dead star nebulas, like the M42, the Great Nebula in Orion, is a star-forming nebula.
Can you have a star cluster inside a nebula?
Absolutely. That's what the Orion Nebula is.
Mhm.
Or the lagoon.
Yep.
Lagoon, okay. Where are we now, Jerry?
We are in the morning sky
Mhm.
at 6 a.m. And this is prime seasoned. The new moon is later this week,
Mhm.
Friday, I believe.
Yeah, it was a pretty crescent this morning.
Okay.
Yeah.
And this is along the ecliptic up here from Mars
Mhm.
down this way. And this is where if you look at this part of the sky, that's where you will see a zodiacal light. If it's if your conditions are right, that is, it's dark, because it's very faint. It's almost as bright as, not quite as bright as the Milky Way.
Oh,
So it goes up here from through Leo and up to Cancer, and yeah,
Virgo down below.
Mhm.
yeah. Okay. So anyway, this is the part of it's close to there's the Big Dipper, Ursa Major.
Yeah. I keep looking for Arcturus, coming up in the northeastern sky. It's real pretty because, yeah, again, I keep saying this is the time of the year you can say good night to Arcturus and say good morning.
Uh-huh.
I'll be darned. I'll be darned. Yeah.
It was a little too hazy, Tim, this morning to see Arcturus, but I was up and looking.
And that one star hasn't gone nova yet, huh?
Oh, you want them in the crown?
Yeah,
Yeah,
in
Corona
I think it's
Borealis.
Coma Berenices.
Corona Borealis.
Yeah.
Corona Boreal, yeah.
Yeah.
I've been watching the astronomical telegram stream and nobody's mentioned it, so it hasn't happened
Okay.
yet.
Oh, okay.
Okay.
Are we gonna visit the Cave Nebula soon?
In a
or-
minute.
A minute.
I can
Because
get you a
of
one-way
the
ticket, Ron.
Yeah.
One way.
I've kind of got a cave nebula here. This is Tim's favorite picture of the false Kiva.
Oh yeah.
Of the
It's
what?
taken from inside a cave.
Wally Pahoka.
Yeah.
Wasn't it Plato or Aristotle that had the cave analogy or
Yeah.
cave problem? I don't remember that. Something about mankind and faking it.
in recognition of Halloween, this is Ursa Tarantula. This tarantula.
Tarantula Nebula. Good Lord, it's walking.
Yeah. They would always come up in Tucson, where I used to live. They would come up during the rainy season out of their holes, and there would be hundreds of them in their yard.
Well, there's a dog in there.
Can you see this?
Yep.
Yeah.
Okay. Some guy put a tarantula costume on his dog.
Okay. Lord.
I was driving up to an occultation where the shadow path was coming down just south of Orchid. And as I went by the San Ynez Valley up there by where 154 hits 101 again, there was a tarantula trying to cross 101.
Oh, yeah.
And I dodged him, but he probably didn't make it.
Yeah.
So we have
well.
them around here. I guess wherever there are rattlesnakes, and we have a rattlesnake canyon, I guess all we need is a tarantula canyon.
Yeah, but Ron, their enemy is, it's called the tarantula hawk, which is a
Yeah.
large wasp.
Oh,
With supposedly the most painful
female
sting in the
lays her
world.
eggs inside the body after she kills the spider.
And you
Doesn't
can
kill
you
the
see,
spider, just paralyzes it.
Yeah, paralyzes it. Yeah,
Yeah.
and,
can
and
you
then they
see
grow up in
this?
the abdomen.
Can you see this share?
That looks really good.
Okay, good.
Are you going to read it, or you want me to read
So
it?
these are clippings from a gosh, I forgot either a Sky and Telescope or an astronomy magazine. I think it's Sky and Telescope. And it compares the deflection of starlight by the sun, which was a prediction of Einstein's general theory of relativity. And it predicts a 1.75 arc seconds for stars located near the sun's limb. They had to, several expeditions went out and searched for this. But before, they had to wait for eclipses. They're not very common. So Einstein proposed a third method, or another method, which is to use Jupiter as the gravitational source and look at the deflection of the light from its moons or from an occulting star. So finally, the deflection was detected by through an eclipse, but some fellows formed a team to try and use Einstein's second method or third method, which is to see light deflected by Jupiter. And so they've picked this field, and there was a near occultation of, I think this star would be within 25 arc seconds of the gas giant's limb. Jupiter usually shows a disk of about 50 arc seconds. So it would actually be about there, twice as close, half as close as it is there. It doesn't give a very as big a deflection as you get with a eclipse, because the
Teeny tiny.
What's that?
Teeny tiny deflection.
Yes,
Yeah.
teeny tiny. But even the one with the sun was teeny tiny.
Yeah.
It's an interesting comparison. They tried this. The equipment that we have these days is way superior to the instruments they had back in the second decade of the 20th century. So getting rid of seeing it around Jupiter is hopefully possible, although they actually, in my view, did not succeed at it. But these are successive pictures of the star going by. And so it's that starlight that they're trying to look for deflection.
And
Now,
Jupiter
this
has ballooned up in their detector to look huge there. You know, I mean,
yeah,
bigger than its actual size.
Yes. And that reflects back on what Ron asked about how could we see something so small? Well, it's brightness that makes it look big. And here, especially when you photograph it, you're picking up all sorts of scattered light, so it looks very much bigger. And it turns out that's the difficulty of doing this method, is getting rid of this glare.
Plus you're seeing, I mean, even that almost 2 arc second deflection for the eclipse, I mean, 2 arc second seeing is considered really good.
Yeah. I think, yeah, when I take pictures with my scope here from not exactly sea level, but I'm at 75-foot elevation. So not very high up in the hills. But the best I've ever seen is 3 arc second diameter stars. And that's a very good night. This shows their data, success or not. I think it's a big not. So the yellow dotted line here follows the theoretical prediction. The solid red line shows the theoretical prediction is the solid red line. The yellow dots and the dotted line is their derived deflection. So it's not clean. They're obviously suffering from too much light, too much deflection. It's glare.
At least it's in the right direction.
Yes, that's true. So a quick note, I don't know their names, but this is the team that is and they used Stan Moore's telescope, which was a 5-inch refractor. I'm assuming that it was a, they didn't identify it, but I'm assuming it was a 127. Who was that guy that, anyway, Al Nagler, yes, Teleview. So this is comparing it to what happened in 1919, eclipse of the sun, for size and difficulty. This is shows their south. I believe this is
Yeah, that's Sobral. That's in Brazil.
yeah, Brazil, yeah. So and this is the telescope they used. They didn't actually use this telescope, but they took the objective out of the telescope since it's easier to carry. And they took it down to their remote site. And that telescope objective is in this laying flat tube down here. And then there's a coelostat that reflects the star field and the eclipsed sun into there for photographic purposes. It's a 13-inch diameter objective glass, so it's fairly big. This has got to be slightly bigger. And they took pictures with that. This is a 4-inch diameter lens in the square tube. And I believe that the best data came from the 4-inch, but and it has a small coelostat too.
Probably because of seeing.
Very likely. So this is an actual photograph taken with the 4-inch telescope plate. The stars are identified by these numbers, and the amount of their deflection is shown. The direction of their deflection, you can't actually see the stars on here. This is a reproduction of a reproduction. So these are the projections, Einstein's predicted things, and the whole thing, okay. And this shows an enlarged star image from the 4-inch telescope, and this shows the actual deflection amount predicted by Einstein.
Wow.
So they're trying to measure.
What mechanism they used to determine the center of that blob?
They tried to identify visually, they tried to identify the centroid of the light spot on the film.
They did a sampling of it? They did least squares or something?
I don't know about that detail. I know that there were several teams that tried to do it, and several teams came up and said there is no deflection. Other ones said there is one, but we're not quantitatively sure about it. And then a couple of teams, or one team, I guess it was Eddington, he got a deflection out of it.
Yeah.
He was able to reduce the data.
Yeah.
And plus, if you combine it with several of the others, you can kind of cheat and say, okay, you know, they form a grid that you can use to kind of estimate what the deflection is. I don't know that you'd exactly call that a direct measurement.
But wouldn't Isaac Newton have understood all of this if he were alive and we told it to him? What's the difference?
Oh yeah, he'd have understood it.
But Einstein's relativity simply said that gravity was something big with a lot of weight warping space-time.
Yeah.
What did Newton say? I mean, when the apple fell, if it did fall,
Here's the deflection calculated from Newton's 3 laws of motion. Here's the Einstein's prediction calculated from general relativity. And here's the best fit to the data measured with the 4-inch telescope.
Einstein's line goes counter corner to counter corner, exactly, doesn't it?
I think that's just scale choice.
That's how you choose the axis.
Yeah.
How you choose the scaling of the axes.
So if general relativity predicts bending of space-time, how do you get a deflection predicted by Newton's laws of motion?
Well, he wouldn't have thought about stuff like that, probably.
No.
Looking at, you know, starlight being bent.
Yeah.
Good question.
Okay. So anyway,
I think there he would have thought that it was some kind of just gravitational effect and the photon was a particle.
That's exactly right.
Right. Yeah, they
And-
call them corpuscles.
And
Right.
the taking the mass of the photon and the gravitational field of the sun, they calculate the offset as it travels by at the speed of light.
I
So-
don't understand how we can see anything 13 billion light years away. You would think a straight line that far without ever being affected.
It's
By
not straight,
anything?
Ron.
No.
It's not
No,
straight.
It doesn't
It
matter.
follows
when
a geodesic in space-time, so you can
Yeah.
consider it straight in that respect.
Yep.
But it's not like a nice straight piece of paper Euclidean plane.
But they all turn into Einstein smiles or blips or whatever. And
It doesn't matter when a photon hits your eye and it triggers one of your cones or rods, then you assume it came to you in a straight line. It could do all sorts of spirals and dances and everything before it got to you, but you will see the sky as if it was straight lines.
Yeah.
Ron, you know
That's
what
how
they
we
say?
perceive it.
You know what they say, Ron?
What?
When a photon hits your eye like a big pizza pie, it's amore.
So I think the big question here could be if the photon has zero rest mass,
Right.
calculate it using Newton's laws. If it has no mass, but of course, when it's moving, it does have mass. It has energy, and energy is mass, and it also has momentum. H over Planck's constant divided by the wavelength gives you the photon momentum. You can back a mass out of it, and then the gravitational pull of the sun will deflect it according to Newton's laws.
Right. You could use effective mass, the photon is E on C squared.
Yeah.
Yeah.
But Newton just gave laws that said this is what happens, this is movement. He
Yeah.
didn't tell us why. He didn't understand why it came down.
That's correct. He had no mechanism, and he wondered for a long time, how
Right.
does this work? Because the concept of a field had not been developed yet.
Right.
So that was invented in 1865 by James Clerk Maxwell when he wrote the four field equations for a photon.
Yeah, Newton's time, Ron, the photon was considered corpuscular.
Right.
Okay, a corpuscle. Okay, so the idea of a wave really didn't come alive until the double slit experiment, stuff like that, early 1800s.
And that fired off the whole quantum mechanics thing.
Mm-hmm.
Well, what I just heard recently is that matter versus antimatter collides, explodes, and becomes a photon. Have you heard that? Is that true? Is that what we're looking at?
It emits a photon and something else, but essentially, yes.
Yeah, anti-neutrino.
Yeah.
Maybe that's where all the antimatter went.
It could be, but then why is there a lot of leftover matter? That's the whole question.
Well, Ron, there was
Were they
antimatter, and then
produced-
there was uncle matter, right?
Uncle matter, yeah. Tia matter.
Save those for the opening of the show there, Tom. Tom Witness.
Yeah, once he gets those puns rolling, it's hard to
Oh,
say.
and they're rolling, yeah.
So sad Isaac Newton's not alive to know all this. I think he'd relish it. He'd love it.
Oh, yeah.
Yeah.
Yeah, he was an unusual genius.
Yeah, he was a little nutty by the end with all the mercury he played around with.
Yeah, yeah.
What's the blue line in the top of this above Einstein? What does that represent? It says best fit. What does that mean?
To
That's
the
the
data
beta
they
best
collected, that's the best fit.
Yeah, so the pink
These
line,
squares fit to the dots that are there.
yeah,
Oh,
the pink line,
okay.
Ron, is theory.
Okay.
And the little
pink-
blue dots and the best fit to the blue dots are from data.
I wonder why it wouldn't land exactly on Einstein's pink line. I don't know.
Because there's
Well,
noise.
Yeah,
There's
Well,
scintillation in the stars. There's,
Mhm.
atmospheric effects. There's all kinds of things when they're taking the data.
Yeah, this would be more meaningful if it had the error bars on it, but
Yeah.
it's close enough for tunnel work here. Okay,
Fantastic. I love it.
now what do we got next?
The cave. Going out to visit a
Yeah,
cave.
Kimball's Cascade, maybe in the cave.
See if
No,
we can
that's
find
that's
a
not.
grizzly Ursa.
The
That's
Cave Nebula,
camelopardalis.
Caldwell 9,
Hmm.
Sharpless 155.
Ah.
Diffuse nebula in the constellation Cephas.
Cepheus.
Cephas right here.
Mhm.
Cave Nebula is right there.
Cephas is whale, isn't it?
It's what?
No,
No.
he's a king.
Cassiopeia's husband, the king of Ethiopia.
Yeah, Cepheus.
Is there a whale a whale
That's
constellation?
Cetus, yes, but
Yeah,
that's
Cetus.
Yeah.
That's what I'm thinking of.
That's a winter thing.
Oh, okay. Well, we're approaching winter.
yeah,
Mhm.
it's coming up now.
Mm-hmm.
Well, get us a close up there, Mr. Prez, if possible. I think Jerry is lost in thought. There we are. You did it.
No, I'm trying to read what I wrote the other night. Sometimes I compose late at night. Need help in the morning.
Well, here you have your star hop from Alderamin and Calf.
Mhm.
Yes.
Oh, yeah.
Yeah, 52 is a real pretty open cluster in binoculars. A small telescope.
Mhm.
Hmm. Those things that look like clouds are over M52 and Cap. Are those nebulae?
That's the Milky Way.
Mhm.
Oh, that's just okay. There's stars clumped in the distance.
And this is what the Cave Nebula looks like
Wow.
to an amateur scope. Let's see, this was an image by John Bozeman, who posts them on Facebook.
You've got to use a cave telescope, though.
Cave telescope.
Yeah.
I don't think he did. Let's see, he usually puts down what the telescope is. It's a AT65 EDQ. That doesn't mean anything to me.
A refractor.
It's refractor.
And
Yeah.
it's on a Takahashi EM11, yeah, EM11 mount,
Okay.
taken from Cherry Hill Observatory.
Oh, that's real famous. Pennsylvania.
Mhm.
That's where they have
He
the
he gives the details of how he processed it and
yeah.
picks
He must have been
inside
at this. He might have been at that star party, Ron. Jerry.
Cherry Hill Star Party. Yeah.
Cherry Hill.
Yeah. could be. It's a nice image. He's resolved these opaquer areas here with faint
Wow.
traces of dark nebula
Mhm.
with a slight red hue. It's an excellent image.
Yeah.
There's a lot of star forming material in here.
Yeah.
New
A lot of
stars being
structure.
made.
A lot of
And it's-
structure.
Jerry,
Or-
I saw this in the workshop, and you were talking about the reddish brown color,
Yeah.
and I can't remember what that was.
That's what filter you use.
Yeah.
Oh, is it?
Is this the cave?
Yes.
Yeah.
This is the cave the cave
And
nebula. But
Yeah.
this
What-
was taken with a 3 nanometer wide hydrogen alpha astrodon filter
Okay.
plus an O3 filter.
okay, and there's
This is a combination of red filter and blue filter.
Mhm.
hmm.
Okay.
There were two separate exposures that got put together in Photoshop or something.
It
Yeah.
could be, he could have done it at the same time, but I doubt it. I think I would do it with two separate exposures at different times.
Or more. And,
But, you know,
and
if
one
the
for
pass
luminance.
bands of the two filters don't line up, then you're not going to get very much.
That's true. Good point. That's why I do it that way.
And probably a separate one without filters for luminance.
Could
okay.
be.
Yeah,
Is
we had a member of the club, Chad. Remember Chad, Chuck?
Oh, yeah.
He used to go to Cherry Hill.
Yeah.
You know,
he
and-
lives in Pennsylvania now, I think. Last I heard.
Yeah. Yeah,
He was
he's
gonna
been
be
to
a
a couple
lawyer.
of those Cherry
Yes.
Hill parties, star parties.
Yeah.
And he met some real famous observers. The two folks who wrote those volumes.
Keppel and Sanner.
That's it. Yeah, he knew them because they would come there.
They would come to RTMC also,
Okay.
or at least
Who are
Keppel
those
did.
guys again?
Keppel and Sanner.
Yeah. So they have those books, Jerry.
The really big observers volumes.
Yeah, I have those. It's really good.
I have Burnham's.
Yeah, the winter and summer and
Yeah.
Yep.
And then Southern Hemisphere. I gave
Southern
mine to
Hemisphere.
Charles Schuler because he has a big enough scope to take good advantage of them.
Yeah, I still have notes from my 18-inch, as little bookmarks on some of the galaxies and stuff.
Well, now does the whole picture show all that red? Is that all the nebula or just the part in the middle?
No, the whole thing is everything that's not dark navy blue is nebula.
And it's a star forming region, right?
That's correct.
Mm-hmm.
A lot of
That's
stars
not
are
the
hidden.
interstellar dust, that's that black area?
Yeah.
This is obscuring dust, yeah.
Yeah.
Okay.
Well, that's the reason it's called the cave, isn't it?
Yes.
Mm-hmm.
Because of those holes. Okay.
See, they
Because of that
look like
one-
holes, but that's tricky. They're not holes.
Yeah.
Yeah.
They're
The dark stuff may
matter
even
in the
have a
way.
Barnard name. It's possible the dark stuff would have a Barnard name.
Yeah.
He was into those dark nebulae.
Drives me nuts trying to imagine what kind of gas obscures everything behind it.
Cold
Carbon.
hydrogen,
Cold gas.
cold gas.
yeah.
Whole glass
Cold gas.
Yeah, gas.
totally obliterates. There's that much,
It absorbs the light.
Mm-hmm.
really.
At certain wavelengths, you can trick it. You can see through it at longer wavelengths, with scatter less. So with radio waves, you can get a good look through.
And it's not just gas. Like Bruce said, there's carbon particles and all kinds of stuff
Yeah.
there too.
Yep.
But still, they're far apart. They're tiny as hell. In space, there's lots of room for light to get through, I would think.
But there's lots of these particles there.
Yeah, lots of them.
where Ronnie, one time, Joe Doyle, we were looking at the Orion Nebula, and there's lots of gases that just completely block the starlight. And he put a Horsehead Nebula, which has a red glow to it, and or kind of a red filter, and you could see the stars poking through the dark nebula, and they were really spooky looking little red dots. It'd be perfect for Halloween.
Yeah.
Suppose there's any chance one of our two Voyagers might run into something like that out there in space?
This is 4,200 light years away, I think.
We're nowhere near a nebula where we are, I guess.
No.
No,
They won't be. If they do, they won't be telling us.
Yeah.
We have to wait.
They
about-
might tell us, but we can't hear it. Yeah,
Yeah.
it's 2,400 light years away.
Wow.
But our sun and solar system, which made the planets, came from the remnants of an exploded star. Is that pretty much what we're looking at?
Probably
The same-
remnants of many exploded stars.
That's
Oh.
why you've got dust.
Yeah.
Okay, it all mingles in space.
Now, Jerry, in a visual telescope with like say a UHC, would we see any of this?
Possibly, it's got a common name, so people look at it.
Yeah.
Okay.
Yeah, big enough telescope. If you commandeered, say, the Mount Wilson 60-inch telescope, you could probably see this.
Might not even need a filter.
Yeah.
Okay.
What if it's possible to see the log of the James Webb and who's going to watch what, when, and how far?
Ron, there was a really thing that happened about that. They
Really?
used to publish, like for the Hubble, they used to publish the future observation coordinates and things like that.
Right.
Because they allocate time for people to look, and they used to publish the date and the coordinates. And Mike Brown was looking at, I think it was Haumea, one of the dwarf planets he discovered, and he was planning future observations to go look at it. And I think this was the case. And some astronomers in Spain were looking at the logs for the Hubble, and they knew he was hunting for a dwarf planet. And so they went and looked at those coordinates and claimed that they had discovered the dwarf planet.
Scooped him.
Yeah. And so now they don't do that.
Okay.
You suppose the foreign governments that hate us can hack into stuff like that?
You know, we
Hack
make
it.
a lot of that public, a lot of the data. The thing is that for the first, if you have a grant and you pay money to get on that table with observing time, then when you get the data, frequently you have exclusive use of that data for like a year or some predetermined time, and then it's all released to the public. So just so people don't get scooped, because some people are backed up with data reduction and someone else might reduce the data first. It's very, very competitive in science and academia to publish first and discover things. I had a guy I worked with at Santa Barbara Research Center that resigned his graduate fellowship from Yale in elementary particles because his thesis advisor was continually publishing his work without crediting him.
Wow.
And so he resigned and left.
Really?
Had a great guy out there at Santa Barbara Research Center.
Wow.
It's very competitive. And not everybody's a nice guy.
Yeah.
Yeah. Wow.
They give you a year of there's like a year that you can use it.
I just made that up. It's
Okay.
usually there's some agreed to time, and I've seen it sometimes as a year.
Interesting.
Well, gentlemen, we're down to the wire. I can't thank you enough for teaching me. If I could just remain to keep it. We'll return again next week, I guess, everybody, for our election week version, number 193 of the SBAU Astro Hour. We'll see you Friday night, the 1st, coming up this weekend for Westmont College's Dr. Ito, talking about her adventures in northern Chile, measuring the cosmic background radiation. It's a freebie. Thanks, guys. Give my
Thanks.
love.